Okay, here we have simplified 2 times cosine squared of theta over 2 times the secant of theta. So I'm going to just rewrite this so I can see it a little bit more clearly. Cosine squared of theta over 2 times secant of theta. Now I know that cosine of theta over 2 is a half angle formula, so I think we'll start there. 2 times, we're going to have plus or minus 1 plus cosine of theta over 2, and then we're going to square that times secant of theta. Now the positive negative multiplied by itself will be positive, and the radical multiplied by itself leaves us just the radicand. And then secant of theta, I can rewrite that as 1 over cosine of theta. Now the 2's cancel, so I have 1 plus cosine of theta. That's all times cosine of theta. That's times 1 over cosine of theta. There we go. I'm not sure if I said that and wrote something different or what, but now that's 1 plus cosine of theta all over cosine of theta. When we multiply straight across, we get 1 plus cosine of theta in the numerator and cosine of theta in the denominator. And now I can separate this out, 1 over cosine of theta plus cosine of theta over cosine of theta. So we're going to try and rewrite this without any fractions. Step 6 should be our final answer. 1 over cosine is secant, and cosine over cosine is just 1. So we end up with secant of theta plus 1. Now if you have not yet tried this one, go ahead and press pause and try it on your own. I'm going to begin working it out. It's actually a pretty quick one. I was able to do this one in 3 steps. Okay, first step, cosine of 2 theta. Let me rewrite this. Cosine of 2 theta over sine of theta plus cosine of theta. So we're going to rewrite cosine of 2 theta to be cosine squared. I like sine squared, but it's cosine squared. Cosine squared of theta minus sine squared of theta. This one we don't really have a choice. We can't just write it in any order when it's subtraction. Over sine of theta plus cosine of theta. But we can rewrite cosine squared of theta minus sine squared of theta to be cosine of theta plus sine of theta times cosine of theta minus sine of theta, because it is the difference of 2 squares. So remember a long time ago we talked about how important factoring is going to be, and it continues to pop up. Now cosine of theta plus sine of theta is the same as sine of theta plus cosine of theta. A plus b is in fact the same thing as b plus a. Therefore those binomials cancel, and our final answer is just cosine of theta minus sine of theta. So hopefully you got that. And this is where we're going to have a glimpse of the future. Why are we doing this simplifying? So that we can verify. So when we verify, we are going to want to make the left-hand side look exactly like the right-hand side. So the left-hand side is the sine of 3x. That's our left hand side. And we want it to equal the right hand side. 3 times the sine of x minus 4 sine cubed of x. This is the right hand side. So the left hand side we'll call LHS, left hand side, and the right side is RHS, right hand side. So my first step is, which side do I want to change? I think I'm going to work with the left hand side. The reason I'm going to work with the left hand side is because I can change the sine of 3x to be the sine of 2x plus x. So now I'm going to go back into that toolkit and pull out the sum formula, the sine of 2x plus x. And I'm going to want that to equal the right hand side. I'm just going to put RHS for now. So step 2, using my sum formula, the sine of 2x times the cosine of x plus the sine of x times the cosine of 2x. That's going to equal the right hand side. Step 3, the sine of 2x, we can rewrite the sine of 2x to be 2 times the sine of x times the cosine of x. And then we have times another cosine of x plus the sine of x times this cosine of 2x. Now, look at what we want that right hand side to be, a sine cubed of x. So I'm going to rewrite cosine of 2x as 1 minus sine squared. 1 minus 2 sine squared of x. Make sure you have your formula written down properly, memorized properly, so that you're using it properly. So we have 2 sine times cosine squared of x plus, I'm going to distribute the sine of x minus 2 sine cubed of x. So we're getting closer to getting that 4 sine cubed of x. Now cosine squared of x can also be rewritten. Cosine, that's an x. Cosine squared of x can be written as 1 minus sine squared of x. That's a Pythagorean identity. Plus the sine of x minus 2 sine cubed of x. I'm going to distribute, and in step 6 I get 2 times the sine of x times 1 is 2 sine of x minus 2 sine of x times sine squared of x is minus 2 sine cubed of x. And as I'm writing this, I can see I have negative 2 sine cubed of x minus 2 sine cubed of x. That's minus 4 sine cubed of x. I can also see that I have 2 sine of x plus 1 sine of x. So 2 sine of x plus 1 sine of x is 3 sine of x. Let's change this color so that you can see. There we go. And then I'm going to have minus 4 sine cubed of x. And lo and behold, that's what the right-hand side equals. 3 sine of x minus 4 sine cubed of x. Once that left-hand side equals the right-hand side, we know that we have done our job, that we have proven, we have verified that this identity is indeed true. It's true, and we verified it. And we verified it in 7 steps. And that's what we're going to be doing in another lesson. We'll be spending lots of time verifying identities. When you verify identities, you have to pick one side of the equation, freeze the other side of the equation, and make them identical.